Hello, topic this presentation, the study of the stability of statically indeterminate frame rod structural systems made of timber, considering the deteriorating support conditions. Problem. The object is to study the operability of the frame rod system in case of sudden loss of stability of one of the racks. As a subject, a frame rod structure made of timber is considered. When loaded, a degrading destruction of the middle rack occurs. A special place in the area is occupied with the problems of studying the stability of the equilibrium of objects. Science very often the process of loss of stability develops almost at lightning speed. It makes it impossible to evacuate people and take measures to prevent destructions. A critical analysis of the current state of the problem of stability of core structures made of timber is carried out. The criteria for the stability of statically indeterminate structural systems made of timber are determined. An experimental plan was developed. The framework under study was designed and tested. Based on the experimental data obtained, graph or clock type sensors readings were constructed, showing the dependence of the deformation of the frame racks on the load applied to the frame, as well as the behavior to deformation during the destructions of the support at a load close to critical. The analysis of experimental data with a determination on the value of dynamic load coefficients is carried out. A calculation algorithm was devised to determine the nature of the destruction of structural system elements and to evaluate the operation of the structure in extreme conditions. The stability criteria can show the conditions of the building depending on the indicator of coefficients of dynamic loads. The physical sign of stability of the equilibrium form in the behavior on the loaded structure when it deviates from the equilibrium position by a certain small amount. Therefore, the compressive load at which the stability of the structure is lost is determined. The critical force. The coefficients of dynamic overloads are determined. In the third stage, the type of bifurcation and the critical force for the pillars on the frame under study are determined. The calculation is performed according to the well-known rules of construction mechanics. The coefficients of the secular stability excitation V are determined, where L is the length of the racks, P is the critical force, E is the modulus of elasticity, I is the moment of inertia of the section of the racks. The coefficients on the free length of the racks are founded by the following formula on slide, and the critical force is determined by the formula on slide, where V is the coefficients of the secular excitation, L is the free length of the racks, E is the modulus of elasticity, I is the moment of inertia of the section of the racks. The work of the racks A is found according to the formula, and the type of bifurcation of the racks on the frame under study is determined, where M is the bending moments, Z is displacement. To analyze the issue of loss of stability of the elements of frame structural system when changing the support scheme of one of the racks, a two-span statically indeterminate frame with a rigid pinching of the supports is considered, and two-span statically indeterminate frame with rigid pinching of the supports of the racks number 1 and number 3, and the hinge movable supports of the racks number 2. Figure 1 and 2 design scheme of the frame under study. For the analysis of partial data, the installation of a frame rod structural system was designed considering the change in the support scheme of one of the racks. Figure 3, the scheme of distribution of efforts. Transfer on the load from the press to the frame under study. During the experiment, the load from the hydraulic press must be transferred to the racks of the frame under study in the form of a nodal load. Figure 4, diagram of the frame under study in a hydraulic press. Figure 5, the frame under study in a hydraulic press. To analyze the measured deformations, watch type sensors were used. The data are presented in Table 1. Based on the experimental data obtained, graphs of the clock type sensors readings were constructed, showing the dependence of the deformations of the frame racks on the load applied to the frame, as well as the behavior of deformations during the destructions of the support at a load close to critical. The critical force is calculated. Determine the theoretical dynamic load coefficients for each node, and the partial dynamic load coefficients for each node are determined. Figure 6, graph of clock type sensors readings. Conclusion. Changing the support scheme of one of the pillars of the frame rod structural system does not affect the type of loss of stability of the compressed curved rods, but affects the value of the critical force for such rods, reducing it. These changes are associated with an increase in influence on the work of the transverse forces and moments. The coefficients of dynamic reloading show the conditions of the building between 0 or 1 normative technical condition, between 1 or 1.15 operable, between 1 or 2 limited operable, more than 2 emergency condition of the building. Operation is impossible. Thanks for your attention.